Hello, this is going to be a fast-paced Python programming tutorial. There are some basic knowledge, minimum knowledge of programming required, such as to know what a variable is. If you do not have the minimum knowledge of programming, head over to my other tutorial, Python tutorial for absolute beginners, 8 hours. And then let's start the fast-paced tutorial. So first of all, we want to have on our machine Python available. If you're on macOS or Windows, you would need to go to downloads and download the latest version of Python for your operating system. And for Windows, there's a installer wizard. You just go next, next, next. For macOS, there's a image file. You need to drag and drop it to the applications directory. On Linux, you install it from using binary packages from your Linux operating system. So it's pre-installed on my operating system, which is Kubuntu 23.10. Next, we will install the integrated development environment and Python text editor, which is named JetBrains PyCharm. We go to download and where is the download? There's two possibilities, Python IDE for professional developers and PyCharm Community Edition. We're going to go with PyCharm Community Edition because it doesn't require any license key. It's gratis. You do not need to have a 30-day trial. So just download for your operating system. Very easy to install. Another way of installing the application in PyCharm Community is to install the application from JetBrains that then allows to install the other applications from JetBrains. That application is called JetBrains Toolbox app. It's available in the main menu, jetbrains.com, as a Toolbox app. You download, you follow the installer steps, and then at the end you have the application installed on your computer. We're going to find in here the product that we want, which is PyCharm Community. This thing. Press the install button. Okay, it says it's downloading. This is because I already have other software from JetBrains installed on my machine. And this is a way for me to have the JetBrains applications installed in the way that JetBrains wants, because I'm using the application from JetBrains to install the products, the other products from JetBrains. Okay, so let's see how we run the application. Not from here, from the start menu. PyCharm Community. I confirm that I have read and accept the terms of the user agreement. So this is the license. Now we go new project. It uses a virtual environment by default, which is great. And then it puts the files in this directory, PyCharm projects. And we're going to, yeah, Python project is okay, the name of the project. And it will create a main.py welcome script. Create. Okay, so this is how the editor for Python looks like. You can put breakpoints. You can start without running the product inside of the debugger. So you just run your source code and you can see in the console the standard output, so whatever our program has written to the console using, for instance, the print built-in function. Or you can start using the debugger, and then you have the buttons to step over, step into, and step out. So now we were on line 13, now we're on line 14, which will print, which will call the function print high, so it will jump now to the line 9 probably. Let's put breakpoints. Step over. Continue. Continue. Okay, and the console is this one. So this is the tool windows for the debugger. Okay, let's stop the debugger and let's start doing the tutorial. We're going to follow the tutorial from Mosh, named Python for Beginners, learn Python in 1 hour. So we're learning the Python programming language because it's one of the better ranked programming languages, for instance, in the TIEOB index. It's on position 1. It's used by major websites such as YouTube. It's the programming language for data science. It's used in automation, DevOps. It's used for science and numerical computation. There are powerful Python frameworks for creating web apps such as Django. Okay, so we have already created a Python project using the integrated development environment PyCharm community. First, we're going to delete the existing Python files. So Python source code files usually have the extension py. They're shown in PyCharm with this Python icon with blue and yellow colors. So let's delete the file. And then add a new file, which is of type Python and which is going to be named up. We're going to create the first Python source code program. Usually in all programming languages, the first thing that you try is the hello world program. So that would be print, which is a built-in function, which will print to the console, to the standard output of the terminal, whatever is provided as parameter. And as parameter, we're going to provide the string hello world. Okay. The error says that it could not open the file main.py. It cannot because we've just deleted this file. So we need to select in this combo box to not debug or run the file main.py, but the current file. And now we can press the run app.py shift plus F10 button. This is the output from the application. This is just a line where PyCharm tells us what process it has started. So it starts Python, and as parameter the full path to the file app.py, which contains our source code. After the Python program finishes, PyCharm displays the exit status of the Python process. So successful processes return exit status 0. So basically you will need to ignore this line and this line and only look at the lines between those two. In this case, it's hello world and then a new line. Okay, so this is a function. These are its parentheses. This is the list of arguments of parameters or parameters. There's just one parameter of type string. Strings in Python can be enclosed in single quotes or in double quotes. And strings are a list of characters, and the storage is immutable. So at position 0 there's a character uppercase H, at position 1 there's the lowercase character E, position 2 lowercase character L. Indexing starts with 0, so the first position is the 0 position, the next is position 1 and then position 2. Okay, so we can run our source code either by pressing this button in the toolbar, run up.py shift plus F10, or from the PyCharm main menu, which is hidden under these 4 horizontal lines hamburger menu. You go to run, and then from there you select either run up.py, which is probably the last Python file that has been run, or run and 3 dots. And in there you have the option of selecting which of the py files, which is Python source code files in your project, should be used when running the project. Okay, so rather than clicking on this button, it's faster to use the shortcut, which is Shift F10. So let's press Shift and F10. Some keyboards do not have the F keys, so there's a special key which with F1 and 0 on it, F10. So in the PyCharm integrated development environment, we have tool windows. The most important one is the one with source code, where various source code files will be open in different tabs. So this is the tab for the app.py source code file. And then there's this tool window, which is called Project Alt+1 tool window, which we can collapse either by clicking on the button with the folder or by clicking on the minus, hide, shift plus escape. At the bottom, there's another important tool window, which is called the Run Alt+4 tool window. Next up is variables. Python, like most programming languages, have variables which represent an area inside of the computer's memory where there's a value, and that area is named, which is the name of the variable. For instance, we can have a variable which is named age, and inside of the variable we have stored the integer whole number 23. So let's say that the age is 23 years old. This is the variable age of type integer. In Python we have more types. Other types could be height, which might be 1.8. This is called a float, so it has a decimal point. It's not a whole number. Then we might have booleans, which have just 2 possible values stored inside the variable: true with an uppercase T and a lowercase rest of the characters, and false with the same capitalization. So let's say I am a human equals true. Okay, and then we already saw how to declare string literals. We can store these in variables of type string. So we might have greeting equals hello world. Okay, Python is a programming language that where casing is important. So lowercase h is different than uppercase h. So these are two different variables. Pay attention to casing. The keyword true exists if it's capitalized like this, uppercase T, lowercase r, u, e, and it's a Boolean literal. If you use cat and you use the wrong capitalization like true, then Python will complain that true seems to be a variable, but you've never declared the variable and it doesn't know what type or value it has. So it says on line 6, which is this line, is a cat equals true. The problem is with these 4 characters, T-U-R-E, all lowercase, which Python does not know about. So true is not defined. Did you want to use uppercase T and then lowercase r-u-e? Yes, that's what we wanted to do. So let's replace the lowercase t with an uppercase T. Okay, so this is a Python keyword, the Boolean literal for truth. So this is for the absence of truth is false. Okay, we can run the program now, so Shift F10. And now it doesn't have any errors. Okay, what are variables useful for? For instance, you can print them to the console, to the standard output. You can go print and then age. Shift F10. It says 23. What does print do is a function that tries to print all of the parameters. There's just one parameter, that's age. Age is in fact a variable of type integer, and its value is evaluated to 23. So print evaluates the value of all of its parameters and prints the final computed value, which in this case is 23, not the name of the variable. If we want to print the name of the variable, we want to do something like this. So we want to print the string AGE, which is something that you can do, but most of the time you don't want to print the name of a variable. You want to print the actual content of the variable. Okay, so this is how we declare a number of variables of different types, but we can also change values of a variable. We can do, for instance, change the age, so declare the variable of type age with value 23 and then change that thing to 40. Shift F10, and now it displays 40. Why is that? Because on line 1 we declared a variable of type integer value 23, and then on line 2 inside of that variable we store the value 40. And now if we're going to read what's the value inside of the variable age, we will get 40. So on line 4 we evaluate what's the value inside of variable age, and now it's 40, not 23, and then we print that 40. So evaluation is first line 1 is evaluated, and then line 2, and then line 4. This is the order of evaluation. Okay, in Python, the naming conventions say that you should separate words with an underscore if you want the identifier, the name of a variable, to contain more than one word. We could have, for instance, an employee age, and we could have an employee name. John. The print function receives a list of objects, so we can have more than one parameter separated by comma, and all of these will be printed, all of the values of all of the parameters will be printed to the terminal with a space prepended inserted between the values. So employee age will be evaluated to 23, a 2 and a 3 will be written to the terminal, and then a space will be written to the terminal, and then JOHN with an uppercase J will be written. So 2, 3, space, and then John. Okay, so this is the naming convention. Separate words with underscores if the name of a variable or of a function contains more than one word. Next up, it says that we should declare a new patient which has 3 characteristics: name, John Smith, age, 20 years old, and a new patient. So for that, we would have patient name, John Smith, patient age, 20 years old, and he's a new patient. Patient is a new patient. And we can print all of these values. Shift F10. Patient. What did I do wrong? So this should have been patient age. Okay, so patient name, patient age, patient is new, patient name, patient age, patient is new. John Smith, space, 20, space, true. Correct. Next up, we also want to read from the terminal we just wrote until now to the terminal using the built-in function print. There's another built-in function for reading characters from the terminal, which is called input. Has one parameter, which is a string, which is the characters that should be written to the terminal. And after that, after those characters, you can enter the characters that you want with the keyboard. So what is your name? Let's see how this thing looks like. So in the Run Alt 4 tool window, it's going to write to the terminal what is your name, so the string that we gave it. We also told it to place a space in the terminal, which is this one. And after it, we are allowed to enter text. So I'm going to write John, which is a possible name, and then I'm going to press the Enter key. When I press the Enter key, all of the characters that I wrote to the terminal using my keyboard are taken by Python and are going to be the result of this function. Okay, so once we have entered inside of our program the characters JOHN, those are going to be returned by the function input. So the simplest way to see that that's what happened is to actually print the result of the input function. So evaluation looks like this. Print needs to evaluate all of its parameters in order to know what characters to write to the terminal. For that, this function is called. This function will write these characters to the terminal. Then it will wait for the user to enter something and then press enter. Once you press enter in the terminal, this function finishes and will return the characters that you have entered via the keyboard into the terminal. And then those characters will be a string and will be passed as the first parameter to the function print. Let's see how that works. What is your name? We need to click inside the run Alt F4. Mary. And again, once you press the enter key, the characters M-A-R-Y are turned into a string that's returned by input. Print has as parameter the string Mary, and then it will print Mary, which is 4 characters, M-A-R-Y. Okay, except from printing, we can also store the value returned by the function input into a variable, into a local variable. And then with the variable, we can, for instance, print it. Should have the same result as the previous version of the program. And indeed, so it behaves identically in the terminal. And now we can greet Mary. We can go hello. Again, print receives any number of parameters, converts all of the parameters to a object or to a string, to an int, and then knows how to print the final value of all of the parameters. So the final value of the first parameter is the string hello, knows how to print that. Let's see how it runs. So knows how to print hello. Then, because print has more than one parameter, it will automatically put a space. And then the value of the final parameter is this 4 character string, which gets printed to the terminal, so Mary. Okay, so apart from depending on how print puts spaces automatically between the values of the parameters, we can also do this more imperatively, where we concatenate the string hello and the space with the value of the string value of the variable name. So concatenation means adding to the values of 2 strings. So from the first string, all of the characters are taken, and then at this position are going to be added all of the characters from the second string. So the characters will be H-E-L-L-O space, and then in our case M-A-R-Y. Okay, so this version of the program has the same effect as the previous version, where we had print hello, comma, and then name. In Python, we can convert from one variable type to another. For instance, we can go from string to integer, we can go from string to bool, from float to string, etc. This comes handy because sometimes you want to do mathematical arithmetic operations on the values returned by the function input. The function input always returns strings. So let's see with an example. We might have a birth year. What is your birth year? And we want to compute the age. Let's store that in a variable named age. and the age would be today's year minus whatever the user has provided. And then we say we're going to just print the age. Shift F10. The first line is executed first and is executed successfully. So birth year is a variable, equals, and then on the right hand side of equals we have a valid invocation of the function input. So the function input displays what is your birth year. We're going to say, I know, 1940. Okay, but then execution of line 2 fails at runtime with the following error. Says 2023 is an integer, but birth year is a variable that has inside the value returned by the function input. The function input always returns the type string. So birth year has actually returned the string with the characters 1940. And Python does not know how to subtract from an integer a string. Says that the operation minus, which is the subtraction, has two operands, one of type integer, which is 2023, and the other type of type string, which is the string 1940. Okay, in these cases, in cases like this, we want to convert from one type to another. So how do we do it? This birth year is the return of the input function, so it's the string 1940. We cannot do 2023 as an integer minus 1940 as a string. We can, for instance, convert this string to an integer. There's more ways of converting a string to an integer. The simplest one is with the built-in function int. Let's see if it runs. So it asks for a birth year, but then it ignores the result because birth year is not used in our product anywhere. We just write to the birth year. We never read from the variable birth year. So age does 2023 as an integer minus 1940 as an integer. So that's valid. The value is the integer 83, which then we print on line 3. So this 1940 should have been the value of the variable birth year. 1940. Okay. So the function returns the string 1940 that gets converted to in the integer 1940, and then arithmetic subtraction operation 2023 minus 1940 is the integer 83 that gets printed on line 3. Okay. Except the conversion from string to int, there are other conversion functions. So there's int, there's float. So we can convert a string to a float type, which contains a dot, a decimal part, and an integer part. And then we can convert, for instance, a string to a bool, or we can convert, for instance, a bool to a string. Okay, let's see some of these conversions. We can straight print the return value of the function int. So we're going to convert 23. 23 is a string, gets converted to int, and then gets printed. Float, we can convert, for instance, 20.15. Let's print this also. Bool, we can, for instance, convert the string true with an uppercase T. And str, we can, for instance, convert the Boolean literal false. Okay, so it prints as expected 23, 12.15, true, and then false. And we can also see the values of these things. Okay, so the first parameter on the first line of the function print is converted to the integer 23. And that integer 23 is in Python class int. Then on second line first parameter is the float 12.15, which Python sees as class float, this thing, the type of that float. And then this is the bool true, and its type is class bool. This other one is the string false, so false surrounded by double quotes, so FALSE characters, printed here, and the type is class str. Okay, next up we should write a calculator application which receives via the terminal values such as a float and an integer, or two integers or two floats, and then writes to the terminal the sum of these two operands. So in this case that's 30.5. Okay, how do we do this? First of all, we need to read the first operand, so that would be input first, and that will get stored into a variable. So the variable first, and then the same thing for the second. So this would be second. Then we're going to compute the sum. We'll use another temporary local variable. So first plus second. And then we're going to print the sum. So again, our program should accept as the first operand both an integer or a float, and as the second operand either an integer or a float. Then it should sum the two and print. So it says that sum is already defined, so we'll rename this thing. Okay, and in here we have the error or the warning that there's no new line at the end of file. So that means the source code should always end with a line that only contains, that doesn't contain anything. So it's an empty line. Okay, Shift F10. Let's see what our program does. So 10.15 and then 20. Okay, so this is totally not what we expected. The result, instead of being 20.15, is 10.1520. So what happens here is that the function input returns a string, so the type of first is string. We can also print these things. So let's do that. So print type of first, type of second, and type of sum. Okay, so again 10.15, and then 20. So first is of type string, second is of type string, sum result is of type string. So what actually happens here is string concatenation. Takes all of the characters from the first string, so 1, 0, dot, 1, and 5. And then at the end of the character 15, adds all of the characters of the second string, which are 2 and 0. And this is the result of type str. This is not what we want. We want to do arithmetic operations with floats or integers. So let's convert first to integer and second to integer. So first is, let's say, 10, second is 20, and it works correctly. So first is a string, second is a string, but sum result is an integer with a value 30. So everything has worked correctly. If the user is careful only to provide integer values, our program is complete. Okay, but then the requirement for this program was that the user can enter either an integer or a floating point, so a decimal number. With decimals, our program will not work correctly. It says that it cannot convert the string 10.15 to an integer because precision will be lost. So the .15 cannot be represented, the decimal part cannot be represented in the final integer. So that's why Python prefers not to allow string conversion when the string contains a dot to an integer, and throws the exception of value error. Okay, what we can do is to not convert the string to integer, but to convert it as to float. Shift F10. So first 10.15, second 20. And now the resulting sum underscore result has type float and the correct value 30.15. Okay, this is if we convert the strings to float when we're doing the addition, but we could also convert from string to float immediately after calling the function input. So we could have written the same program with the same behavior, like so. Okay, first, and then float second. Let's run the program, make sure it's identical to the previous version of the program. So first 10.15, second 20. And now first is of type float, second is of type float, and some result is also of type float. We're only using strings because that's what the function input returns, but then immediately we're converting everything to float. So then all of the local variables, all three of them, are of type float, and our program will respect the specifications. Next up, we will look at strings. So let's have a variable of type string. Of course, let's make this Python tutorial. So this is a string literal. This is a right-hand side. This is a left-hand side. This is the name of a variable. This is the declaration initialization of a variable. This string literal is an object and has many methods. You can press a dot character, and now you can see all of the functions that are part of the type of this string literal, which is class str, which we saw previously. Let's put a comment here. Let's see the type of this string literal. So it's class str. Not only variables have type, but also the literals have type. So this is a string literal, is of type string. This is a variable of type string. Okay, so both course is of type string, also this string is of type string. The string is also an object, and objects have specific functions which are part of its own type, which are called methods. So let's see what methods are available for strings. We go the name of the variable dot, and then we can see a large number of methods. The methods are the one with the icon m, lowercase m, and there are methods for capitalization, such as upper, lower, and upper. There are methods for finding characters inside of a string. Yeah, there's rIndex, rFind, there's index. Okay. There's methods for trimming the white space around the string, or splitting a string based on a separated character such as a space. So for instance, we can split this string into an array of a list of two strings, Python and then tutorial. The space is going to separate the two elements of the new list. Okay, so in Python, strings are immutable. There are certain operations that you cannot do on the value that's stored inside of a variable. And for instance, the methods that convert the casing, such as upper. So the string has the method upper, converts the value of the string to all uppercase characters, returns that, but then the object remains unchanged. Okay, so inside of the variable course we have Python tutorial with just uppercase P, and then we tell it call the method upper on the object of type string named course, but then the course itself stays unchanged. It's just this method returns a totally new string with all of the characters uppercase. So there will be uppercase P, uppercase Y, uppercase T, etc. Okay, so although this method returns the same characters as the input string, which is course, but all of the characters converted to uppercase, course itself remains not changed because we print it on line 3 and we can see it has the same original value that was set when the variable course was declared on line 1. Other methods of the type string, there's lower to make it lowercase, so lowercase p, but again the objects of course remains not changed. Then there's methods for finding things inside of the string. There's find, and as parameter expects a string, so we can search for tu, and this returns an integer, which is the position where this substring tu was found in course. So the first position where the string to find appears in course. So the string to find is tu, its first position, so the first index where it appears when searching from left to right inside of the string. So we're searching here tu, no tu, this is not tu, this is not tu, etc. The first position where it finds tu is this position. But then what's this 7? So strings in Python are a list of characters and they have indexes. So the first character in the list has index 0, the second has index 1, the third character in the string has index 2, etc. Okay, so this 7 is actually the index of tu, which is the same index as the first character in the string to find. So the index of this t, 7. We saw it written to the terminal here. Okay, so we can pass a string in here, but we can pass also a string of just one character, such as lowercase y. So, or let's go with lowercase o. So lowercase o appears twice in the string. If we go left to right, first time it appears in here at index 4. And the second time it appears here at index 10. Okay, so at index 4, there's the first O. Then searching in strings is case sensitive, so pay attention to the search string, so the string that you search for, should have the same capitalization as the string that you search into. So uppercase O does not exist in the string. And in that case, the method find says I could not find uppercase O in the string, so in course. It returns -1. Next up is the method replace, which receives two parameters, the old string and the new string. Okay, so we want, for instance, to replace tutorial with course. So how the method replace works is it searches for this substring inside of this string, finds it at position 7, ending in here, so it removes what it finds, instead puts the new string. So it takes this thing, replaces the first string to find with the new string. This is the result Python course, course, as we saw in here. Of course, the original string, so the variable course, remains unchanged. Replace returns a new string. Okay, if we tell course to replace inside the string a substring that does not exist, such as, what's this, lesson? The substring lesson does not exist in Python tutorial. There's nothing to replace with. So course.replace will return the value of course, which is Python tutorial, as we can see it in here. Okay, then let's look at the operator in. We have a variable and we want to know if tutorial exists in course. So course, the object, the local variable, in, the in operator, and returns a Boolean value of true if the string course contains tutorial, which it does. Returns false if it does not. So this program should return true for line 3 and false for line 4. True and false, correct. Okay, next up, let's look at arithmetic operators. Operations. Okay, so we can add two integer values. We can subtract two integer values. We can multiply two integer values. We can divide integer values. Let's look at the results. So this is integer 10 plus the integer 3, integer operation addition 13, correct. Integer division 7, correct. Integer multiplication 30, correct. But this is a bit surprising. It's not actually doing integer division, it's doing division, numeric division, which returns a float. So returns 3 dot period 3. If we want integer division, there's this. So / operator does integer division. And when you say integer division, you want to know what's the remainder and what's the modulus. Okay, so you take 10, you integer divide it to 3, that's 9 divided by 3, that's 3. And then the remainder is 1. So modulus operator, arithmetic operation, returns the remainder. And then / does integer division, returns an integer. / does numeric division, which will return a float. Okay, and another operation would be the power of. So that's 10 to the power of 3. That's 10 times 10 times 10, which is 1000. We can see it in here. Okay, so this is the binary operator. And then there's also equals plus a arithmetic operator. Okay, so let's look at arithmetic operator and followed by a equals sign. So let's say we have a local variable type integer with a value 10. We want to increment this 3 times. So we want x to become a 13. So how we would do it is take the value that's already stored in x, which is 10, increment that with 3. So do 10 plus 3. This is the right hand side. X is evaluated to 10. We're looking inside of the variable. We see that there's a integer 10 stored there. We can add 10 plus 3 because they're both integer. And then the return value will be 13 integer, and we'll store inside of the variable x this integer 13. Okay, and now inside of the variable x, the value is no longer 10, but 13. And the variable x remains of type integer. Okay. This uses 2 lines. We can write line 3 in a different way. So instead of writing x equals x plus 3, we have a bit of a shorthand notation, which is plus equals 3. The two programs should be identical. So x used to be 10. The value that's inside x has been added to 3 and then stored back into the variable x. So now there's 13 inside of the variable x. And the type remains the same for the variable x, integer. Similar to this, we have the other arithmetic operations plus an equal sign. So we have x minus 3, it's 7, x divided by 3, it's 3 dot period 3, and it's a float, not an integer, because this is numeric division. We return a float if needed, otherwise it can return an int. If we want integer division, that's 2 slashes and an equal. and now x is back to type integer, has value 3. There's modulus. Modulus always returns integer, so the type is integer, and the value is 10 minus 9, which is 1. Okay, and the last one that we looked at is the power 2. Okay, so takes whatever value is inside x, multiplies it with itself 3 times. So 10 times 10 times 10, that's 1000. Type integer. We have looked at various arithmetic operations, and each programming language has a thing that's called the operator precedence table. This is what I have searched for on Google, so Python operator precedence table. There's a ton of images, and then there's also the official documentation which has this table. So in here we can find out that addition and subtraction have lower priority compared to multiplication or integer division, for instance. Let's see how that works. So the higher the precedence, the higher it is on this table. So parentheses are have the most priority, whereas assignment expression has the least priority. Okay, so let's say we have x, which is 2 plus 3 times 4. What's the value of this? It's 14. So it's 2 plus 3 times 4. How does it get evaluated? By following the table of precedence. So it's not going left to right, because if there was no precedence order, Python would have computed this right-hand side in left to right order. So that would have been 2 plus 3 equals 6, and then times 4, that would be 24. But because multiplication has better priority than addition, this binary multiplication operation is interpreted first. So it's in fact computing 2 plus 3 times 4, which is 12, and equals 14, which we can see it printed in here. If we do not like the way Python computes an expression with many binary operators, we can put parentheses to signal to Python that we want the addition to take place first, to be evaluated first, and only then the multiplication should be evaluated. So 2 plus 3 is 5, times 4, it's 20. So correct. Okay. So parentheses will change the order in which operations are performed. So we have looked at the operators exponentiation, multiplication, division, floor division, remainder, addition and subtraction. Next up, we're going to look at the comparison operations. So comparison operators. These return boolean, so return true or false. Let's see. First, less than. So 9 less than 3. Not, so it's false. 4 less than 6. True. 4 is less than 6. We have the less than or equal. Returns true because 4 is less than or equal to 6. Returns true because 6 is not less than 6, but 6 is equal to 6. So 6 is less than or equal to 6. Okay. We can compare if they're equal with two equals. 6 is not equal to 7. Okay, so that was less than or equal. There's also greater than, greater or equal. And there's different. So 6 is different than 7. True. Okay, the worst priority in the table is assignment. So this is the assignment. This makes sure that the entire right-hand side is always gets computed completely, and only then the operator with the least precedence possible is assignment is going to be evaluated. So it's going to compute this, which is the boolean false literal, and then it's going to assign it to x. So x will be type boolean with value false. Okay, and this is the assignment, just one equal. If you want to compare two values for equality, you're going to use equals equals. So this convention exists in other programming languages such as C, C++, C#, Java, etc. So this is assignment, just one equal. This is equality comparison, two equals. Okay, next up we're going to look at the boolean not, boolean and boolean or. So these three. So let's say we have a local variable named price, and the price is 25, and we want to make sure or test if the price is between 10 and 30. And print if price is between 10 and 30. So we might go price is greater than 10. We already know how to do this. We use the comparison operator greater than, returns true. We also may need to make sure that price is less than 30. And it is. But we're interested if both of these comparisons are true at the same time. Okay. For instance, for the price 5, 5 is not greater than 10, but is less than 30. So we want to print true only if price is both greater than 10 and less than 30. Okay. For that, we would use the AND boolean operator, which can be written like this. If you want to make it more explicit for the reader of the source code, that this is the order of operations that you want, that you meant. So you want to compute if price is greater than 10 and price is less than 10, and then at the very end apply the Boolean AND operator. You can use parentheses. But then we can see from the table of precedences that AND has a really low precedence compared to the comparisons. Okay, so the comparisons are 7th worst precedence, whereas AND is 5th worst precedence. So well, you can write it both with many parentheses or with less parentheses. Let's put a new line, Shift F10. So it's the same thing. Personally, I do put parentheses to make it more clear where the left hand side of AND ends and when the right hand side of AND ends. Okay. Next up is OR. So we can see how OR Boolean binary operator works. So there's the left operand and the right operand. If one of these is true, then the entire operation returns true. Okay, so in this case 25 is greater than 10, 25 is less than 30. The left operand is true, the right operand is true, then the result of the entire operation is true. You can see it in here. But if only one of the two operands is true, then that's enough. So for instance, 5 is not greater than 10, this will be false. But 5 is less than 30, so this will be true. The combined result, the result of the operation OR, will be true because the right operator is true and the left operator is false. If at least one operand is true, then the result of the operation is true, which it is. Okay, and the last one is this, that has a better precedence than AND, which is operator Boolean not unary operator. So it has just one operand. So one of these two is false, which is price greater than 10. We can put as many pairs of parentheses as we want. It's the exact same thing. And the Boolean operator not is not, and then just one operand on the right hand side. Okay? So price greater than 10 is 5 greater than 10, which is false. So this entire parenthesis is false. And then we are negating that false, and then we will get a true. So it flips trues to false and false to true. This was false. This thing is true. Okay, so until now, the Python interpreter has interpreted all lines in the order that they were written into. So first it went to line 1, then to line 2. But we can have other ways for the Python to interpret, other order in which the Python interpreter will read and execute our lines. One of these possibilities is the alternate structure if. So let's use degrees Celsius for temperature, and we're going to see if the temperature is hot or not. So we have temperature 35 degrees, that's a lot. And then we use the keyword if to introduce a if statement. If should be followed by a condition. For conditions, we're going to use the comparison operator, so temperature greater than 30, and then the if line ends with a colon. So keyword if, condition which needs to be evaluated to a boolean, and then colon to end the if line. Press enter, and the integrated development environment PyCharm has indented, so 1, 2, 3, 4, has put 4 spaces at the start of the line, so it has indented the line 4. And now we're inside of what's called the then block. So the then block is if the condition is true, it goes on the branch yes. So this thing is the then block, the block that gets executed if the Boolean condition is true. So it should print that it's a hot day. Okay. And if we're going to press enter after we finish line 4 to advance to line 5, we are still inside of the then block, and we can put more lines inside of the then block. Okay, we can have as many Python source code lines as we want. As long as they're indented, we're still inside of the then block. So Python does not use curly brackets that surround blocks of code like this. So blocks of code are surrounded with curly brackets in the programming languages C, C++, Java, C#, etc., JavaScript. But Python uses indentation to signify that a code block has started or ended. Let's actually run the code, Shift F10. The temperature is 35. The condition in if is 35 greater than 30 true. So the then block gets executed. The then block contains 3 lines, 4, 5, and 6, which just print things to the terminal. So we can see in the terminal the 3 texts are being printed. If the temperature is lower than 30, let's say 25, then here on line 1 we declare a variable named temperature value 25. On line 3 the condition is evaluated, so 25 is not greater than 30. This condition is false, so the then block will not be executed if the condition is false. So as you see in here, condition true, then it goes to the then block. If condition is false, it will not go to the end block, to the then block. It will actually go around the end block and start executing all of the source code lines that are outside of the if statement. So this is the if statement. This is the then block. This is the else block. And this is the condition of the if. Okay, let's show this. This is the then block. This is outside the then or the else block. It's actually outside the if statement. It's this thing. Execute code outside the if block. So this is code outside of the if block. Line 7 will get executed no matter what temperature is, no matter what the if statement does. Okay, so if the condition in the if is false, line 7 is executed. If the condition inside the if statement is true, line 7 still gets executed. But then because the temperature is greater than 30, it's 35, condition is true, execution will also evaluate the then block, which do their thing here. Okay, so what else can we do with if statements? We can have two of them. For instance, if the temperature is greater than 30, we have this if for that, but then we can also have another if for if the temperature is less than or equal to 30. We could say something like this. If the temperature is -1, then the temperature is not high. Okay, so if you have two ifs, one after the other, with totally opposite conditions, you can merge them into just one. Okay, so the condition of the if is if temperature is greater than 30, but then if temperature is less than or equal to 30, this code block will be executed, which is called the else block. So this is the else block if the condition is not true. We evaluate the condition, -1 greater than 30, it's false, and then the else block gets executed. So print the temperature is not high. And then we can also have more fine-grained intervals in our case. So we have temperature greater than 30, that's temperature is high, but then we can also have else if temperature is between 20 and 30. So that's part of the else block, but inside of the else block we add another if temperature greater than 30, so if then 20. If temperature greater than 30, it will go on the then block. If temperature is 21, it will not go to the then block, will go to the else block. But then inside of the else block, we also have this if temperature greater than 20, which it is. And then it will print this. And we'll end everything with an else for all of the other possibilities. So if temperature greater than 30 will go here. If temperature greater than 20 but less than or equal to 30, it will go here. For all other values, it will go here. The temperature is great. Okay, the temperature is not that great. -1 is below freezing in degrees Celsius. So the temperature is not that great. If we go with 30, which of the three possible blocks will be executed? Then, the else if, or the final else. So 30 is not greater than 30, but it's greater than 20. So this part will be executed. So in mathematic notation, that would be the interval 30 and then infinity. This is the interval 20 and 30 inclusive. And this is the interval minus infinity and 20 inclusive. These are comments, a pound or hash sign. This is a mathematical interval. So starts with immediately above 30, not including 30, and goes to 31, 32, etc. until infinity, positive infinity. The else if branch is for the numbers that are strictly greater than 20, so excluding 20, but then not greater than 30, so less than or equal to 30, inclusive 30. And the only other possibility is inclusive 20 and then 19, 18, etc. going down to minus infinity. Okay. 30 is a great temperature because it's 30 inclusive. It's part of the else if block. Whereas 31 is greater strictly than 30. So it's in this interval, the then block gets executed. Next up, we're going to create a program that converts either from kilograms to pounds or from pounds to kilograms. It will write on the terminal weight and then space. The user will enter a value, for instance 100. Then it will write to the terminal kg or lbs. The user should enter a lowercase l, uppercase L, lowercase k, or uppercase k. And then depending if you want to convert from pounds to kilograms or from kilograms to pounds, we're going to perform the calculations and write the result to the terminal. So let's see how we implement this program. First of all, we need to print this thing. Okay, in order not to lose what the user has given at the terminal, we're going to store that string returned by the input function into a local variable. So this is weight either in kilograms or in pounds. And then we need to put this question. And store the response from the user into a local variable. So this is a variable of type string, might be lowercase k, uppercase k, lowercase l, uppercase l. Okay, this will want to be a float. And then we're going to do the conversion using this number. So 1 pound is 0.45 kilograms. 45 kilograms is 100 pounds. Okay. We are going to do two different conversions from kilograms to pounds and another one from pounds to kilograms. So we're going to use an if statement. In the then body, we will have the conversion from kilograms to pounds. In the else body, we will have the conversion from pounds to kilograms. So if we want to convert from kilograms to pounds, equals to string k. Okay, this is the kilogram to pounds. And on the else branch, we will have the conversion from pounds to kilograms. Okay. Let's put the bodies of the then and the else. So kilograms to pounds, that's kilograms. So weight in kilograms. And we want to divide this non-integrally with 0.45. Let's put even more decimals. 3.5. Okay, and then we want to print in this format. Okay, let's run the program. So it says that just a comment is not enough to make for a block. The keyword for empty blocks is pass. Okay, Shift F10. So it says weight, let's go with example 100. It's kilograms. And it doesn't not like something. What doesn't it like? So we do non-integer numeric division. This is a float, so this part is correct. But then weight is incorrect because it says unsupported operand types for division operator. On the left operand is of type string and the right operand is of type float. So what we want here is weight to be a float. This is already a float. This way the user can input 24.5 kilograms and then say that those should be converted to pounds. So we do that by converting this string to a float. Shift F10. So weight 100. No, let's go with 20.50 kilograms. So this should be, in here we ask this weight value that you just provided, is it kilograms or pounds? So this should be weight in pounds. So let's run the program. Says 20.5 kilograms. And it doesn't print anything, it doesn't convert anything, it doesn't interpret lines 10 and 11. Why? Because we gave it a lowercase k, not an uppercase k. So this unit is lowercase k, this string is uppercase k, they are not identical. So then how can we compare them in a case-insensitive way? We can convert this string, which might be an uppercase k and lowercase k, an uppercase l or an uppercase or a lowercase l, to be always uppercase. Okay, so now there's only two possibilities in the left hand side of the equals equals. Might be uppercase k or uppercase l. Uppercase k, then branch, uppercase l, else branch. Okay, 20.5 kilograms, and it gets converted correctly to pounds. There's more pounds than kilograms, so that's a good sign. Let's do the else block. So we need to convert from pounds, which are more. We're multiplicating them to something that's less than 1. So this is going to be less than this. This should be kilograms. And that's about it. Weight 20.5 kilograms. And weight 100 lowercase l, which means pounds, and should be 45.35, which it is. So the program seems to work okay. Okay, so next we have in here, after weight in kilogram colon, we have two spaces. Why? Because we have one space here and another space is put automatically by the print function. After it finishes putting the characters from the first string, it puts a space and then it puts all of the characters from the second string. So in order to fix this, we want just one space in here. We either remove this space and now there's just one space here, or we can do a string concatenation. Okay. The string concatenation fails because converted is weight and weight is float. So float and then an arithmetic operation with another float is float. So converted is float and weight in kilogram is a string, so it doesn't know if I want to do string concatenation between a string and another string or if I want to do a float addition between two floats. So I need to choose between these two. And for that, I'm going to convert the float to a string. Okay, Shift F10, 100, lowercase l, and now it works okay. So this, if you want to pass just one parameter to the function print, and that's going to be a string that you are going to create yourself using string concatenation and other possibilities, conversion to string format, etc. Or you can use print with multiple parameters as we did before. So these lines 5 and 6 are a sequential source code structure. This is an alternative source code sequence. A source code structure of type alternative. So it either runs these lines or these lines based on this condition. So sequence, alternative, and then there's the third type of source code structure, which is repetitive. Let's see how that looks like. So we might need to print many numbers in a sequence. What if you need to create a program that needs to print these numbers from 1 to 5? Adding many lines which are very, very similar to one each another is tedious, and in this case there's just 5 lines to print. It's still manageable, but what if you need to print all of the numbers between 78 and 247? In cases like this, where you need to do a similar job multiple times, that's where you want to use repetitive structures. And we'll start with a repetitive structure named while. Okay. For using the while block, we will use a syntax like this. We will have a local variable for the loop. We can start from 1. Most of the times you will actually start from 0, but let's make an exception this time. Inside of the while, similar to the if instruction, we have the keyword while, then a condition, then we have the colon. If we press enter, now we're inside the body of the while. Here is what we are going to try to do in our program. So we start from before the condition. We evaluate the condition. If it's true, we're going to execute the body of the while, of the loop. Then we're going to return at the condition. Is the condition still true? We're going to execute the body of the loop again. We're evaluating again the condition. Is the condition still true? Yes, we execute the body of the while again. And then we evaluate again the condition. This time is false. And we're not going to execute the body of the loop again. We're going to go on this line where it says false. And we're outside of the while structure, the while repetitive structure. Okay. So we're now implementing this thing, the body of the while loop, which in our case, we need to repetitively print numbers starting from 1 and ending to 5. And then this is a thing that will make the product, the program not print 1 forever. Let's execute it like it is right now. So it prints 1,000,000 times just 1. Why is that? Let's run the program line by line. So line 1 says declared local variable of type integer named I with value 1. Then as long as this condition is true, we're going to run this body. So I is 1, which is less than or equal to 5, which is true. So we print I, which is 1. I is 1, less than or equal to 5, which is true. Print I, which is 1. 1 less than 5, print 1. 1 less than 5, print 1, etc. So how we actually make this loop do what we want, which is print 1, 2, 3, 4, 5, is to actually increment I. So we go I equals with I plus 1. Okay, let's run it manually. So I local variable equals 1, I less than 5 because 1 less than 5, so true. Prints I, which is 1. Then I plus 1 is 1 plus 1 is 2. So 2 is assigned to the variable that already exists, named I. Then the body of the while ends. The body of the while has 2 lines, 3 and 4. It returns at a condition. I this time is 2. 2 less than or equal to 5. This thing is true. The condition is true. So the body of the while is executed again. The body of the while has 2 lines, 3 and 4. So it prints the current value of I, which is 2. Then 2 plus 1 is 3. I is assigned the value 3. We're out of the body of the while loop. It evaluates the condition again. I is this time 3. 3 less than or equal to 5, true. Then it goes through and executes the body of the loop, which says print, and this time I is 3. 3 plus 1 is 4. Now I becomes 4. The body of the while finishes, goes back to the condition 4 less than or equal to 5, prints 4. 4 plus 1 is 5, I equals 5. Goes outside of the body, 5 less than or equal to 5, true. Executes the body of the loop just one more time. Print I now it's 5, so it prints a 5. Then 5 plus 1 is 6. I is assigned the value 6. The body of the while loop ends and goes back to the test condition, which says 6 less than or equal to 5, which is false. And now it does not execute the body of the while, so 3 and 4. Jumps to the next instruction, which is outside of the while structure, which is on line 5, which is nothing. The program terminates. Okay, Shift F10. So it prints correctly what we wanted, 1, 2, 3, 4, and 5. Okay, so now we know how the repetitive structure while works. We told it to print the numbers from 1 to 5. We can print the numbers from, I don't know, 25 to 1000 to 100, let's say. Shift F10. Ends at 100 inclusive because we have I equals then 100. And starts at 25 inclusive because in here we make I equals 25 and then we print it. Okay, we can print even larger numbers such as 1000. Okay, We can use the underscore separator for thousands and for millions. It's the exact same as writing without underscore. Next, let's look at multiplying a string. So for instance, we want to print one asterisk or two on the first line, two asterisks on the first line, on the second line, three asterisks on the third line, etc. So this is the operator between a string and an integer, which takes the string and concatenates it with itself this number of times. So I at the start will be 1, so asterisk will be concatenated with itself just 0 times, so just one asterisk will be. And then if I is 10, this operation will generate a string with 10 asterisks, which then will be printed. Okay, so starts with one asterisk when you multiply asterisks, the string containing just the character asterisk with 1, and ends with this one, which is 10 asterisks, which is the string asterisk multiplied with the integer 10. Now that we know the sequential structure, alternative structure, repetitive structure, we're going to look at other types of data in Python. And the next one is a list. So let's say we have a variable named names, and inside we have a list of names. Let's see what's inside here. Okay, so we have declared a local variable of type array, of type list, because in here we can see its type, so it's class list. And the list contains 4 objects, could be of any type, but in this case all 3 of them are of type string. The order matters in a list. You can get at the first item in the list by using the index 0. This is index 1 and this is index 2. You can replace the object which is at any index, such as we can replace Anna with something else. You can insert items between elements in a list. You can prepend or append items in a list. You can look at the size of the list. So let's see all of these operations one by one. First of all, we're going to see how we get to Mary. That would be print names of, and then index 0, 1, 2. Let's also see its type. Okay, so Mary is a string, is inside the list names at position 2. In Python, we go 0, 1, 2 with indexes inside of a list, but we can also provide negative numbers, negative integers. Okay, so 0, 1, 2, and the list will then wrap like this. So this is index 2, index 1, index 0, and then below index 0 there's the list again. So this is index 0, this is 1, and this is 2, and then below 0 there's the negative integer, so -1, -2, and -3. Okay, so let's see what happens when line 5 gets executed. Says names of -1 is Mary, and that's a string. Okay, let's check with -3. Should be John, and it is John string. The next operation is to remove an element from the list and put something else in its place. So we can do that like this. Names of 0 offers us the current version, the current value inside of the position 0 in the list names. So we read from position 0 names, but we can also write to the position 0 in the list names by using the assignment operator. So we treat this as a regular variable name, like names. Okay, so we can make this thing Johnny. Okay, and now on position 0 where John used to be, we've put a different string, a totally different string. We did not edit this string, we just put a totally new string on the same position in the array. So instead of John, now we have Johnny. So Johnny, Anna, and Mary. Correct. Then we can select not just one, return not just one element in the list, but return a part of the list, a subset of the list. So for instance, we want to return a new list that contains just these two items, John and Anna, whatever, Johnny and Anna. So we do that by not doing this, because this will return just the string John, whereas we want to return a list containing the two strings John and Anna. We're going to use the colon, and then we're going to specify the index, the first index that we do not need. So the first index that we do not need from the list 0, 1, 2 is 2, Mary. We only want 0 and 1, we do not want 2. So this is the first index that should not be returned. And this is the first index that should be returned. Okay, so what this slicing operator returns is also a list. And this list contains just two strings, what we expected, Johnny and Anna. Okay, so we'll represent that in mathematical notation. So means we want index 0, but we do not want index 2. So excluding 2, but including 0. And this returns a totally different and new array, a new list, and leaves the list names alone, does not modify it. Let's check. And indeed, the variable names continues to be a list of strings with 3 values, Johnny, Anna, and Mary, whereas names and then the slicing 0 from 0 to 2 returns a totally different new list with just 2 items of type string. Okay, so we saw the methods of the type string. Let's now look at the methods of the type list. We'll have a simpler list of integer elements. 1, 2, 3, 4, and 5. Let's see what methods are available for the object numbers. So we go numbers dot, and then there's clear. I know what this thing does. It creates a new list which is empty. Sort, and also has a parameter to sort in reverse order. Append to put a new item at the end of the list. Insert to insert a new item at the given index. Remove a list. Reverse, so let's make the list 5, 4, 3, 2, 1. Let's go with reverse. So we go print. Okay, so numbers dot reverse actually mutates the list. We can see it not returning anything on line 2 here. And then when we printed the numbers, now they are in a different order. So they used to be in the order 1, 2, 3, 4, 5, and now they're in the exact opposite order. So 5, 4, 3, 2, 1. We want to append a new item, so we go numbers dot append, and what should come next? 6. And now the list is 1, 2, 3, 4, 5, and 6. Okay, this is for inserting at the end of the list, but then we can insert in any other position, such as before the position 0, before the position 4. For that we have the method insert. And the parameters of the method insert are an index. So we want to prepend, that's index 0, so right before the value 1, that's stored at index 0 in the list numbers. And then we can pass anything. We can pass a string, literal, an integer literal, a float literal, a variable, etc. We will put a -1 in here, Shift F10. So the list now has not 5 elements but 6. Starts with -1 because this is position 0. At position 0, so before position 0, we have put a -1. So -1 is now on position 0, and then 4 is in position 4. We can also remove elements. Okay, and it says the value that we want to remove. So we're not removing at index 0, but we're removing the value. So the value that we want to remove is 2. Okay, and now there is no 2 in the list. Let's see what happens if we have 2 twice. It removes just the first 2. So it removes this one and then leaves the second apparition of 2 alone. Okay, and we saw that the first possible member in order of in alphabetical order was this thing, which is clear. But now the order has changed because we have preferred other methods. I do not like the auto-completion in PyCharm. I always disable it as much as possible. I know how to print characters and I will do them. So PyCharm, please do not put parentheses and other characters when I did not type them. Okay, so clear. I'm not sure in which order are things displayed in here. Sort by name. A sort by name is a bad idea because then the double underscore methods are the first ones. These methods are called double underscore. Okay. So we know that many methods of the list object actually mutate the list. So this is what clear does. Goes at position 0, removes the item, goes at position 2, removes. And at the end, a list is returned, but an empty one. Okay, so it's the empty list, but we can see it's a list because it says class list, and because it uses the syntax open and closed square brackets with nothing inside. Okay, other possibilities, we have the in operator. Let's see if 0 is in numbers. It's not, returns false. Let's see if 3 is in numbers. Control S. 3 in numbers, yes, because we cleared it. Okay, correct. So 3 is in numbers, -1 is not in the numbers. And if the list is empty, in will always return false. And the len built-in function gives us the size. So the size of numbers is a list with 5 elements. Len also works for strings. Because strings have some similarities with the list in the sense that they contain a list of characters. You can find out which character is at position index 0, for instance. You can use the built-in function len. Next up, let's use another repetitive structure, which is a for loop, which is similar to a for each in C# or a range for in C++. So let's have a list. 1, 2, 3, 4, and 5. And the syntax for the repetitive structure is for. Then we have a loop variable, a variable that always changes its value after each iteration inside the loop. So we can name this thing, I know, item or number, for instance, in numbers. And then the block, the body of the for. In here we might have print and item. Okay. Why did we need this time a repetitive structure? Because if we just print numbers, the line 3 is going to write on the terminal square parentheses 1, 2, 3, 4, 5 with comma and space separated. But we wanted to have printed a 1, a new line, 2, new line 3, new line 4, new line 5, new line, which is what line 6 does. So line 6 prints these lines, and the source code line 3 prints this line. Okay. So how this thing works, we have a list, and the for loop starts at index 0, takes from the numbers the item of this. So item becomes the element at the first index in the list number, so 1. We run the body, which just has one instruction. We print the current value of item, which is 1. Then we return at line 5. In item, we put the next element inside of numbers, which is the index 1, which is the integer 2. So item is now 2. Then we execute the entire body of the for, which has one line, prints 2. Then execution returns on line 5. Item was here, now becomes 3. Then we execute the entire body of the loop, just one line, print 3. Back to the line 5. Item was here, now item is here, so item is 4. Then executes the entire body, prints 4, back on line 5. Item was here, now it's here. Executes the body, which prints 5, and then returns on line 5. And item was here, and now item cannot jump outside of the list. So execution of the entire repetitive structure ends, and now line 7 will be executed, which is empty. There's no more source code lines, and the execution of the Python script will stop. Okay, so this is a repetitive structure. We already know of another repetitive structure, which is while. We can write a program that's equivalent to this one using the while repetitive structure. The source code would look something like this. We have a loop variable. We need to start at index 0. Then we go while I is less than, so I should go 0, 1, 2, 3, and 4, should not arrive at 5. So that's why I less than, and then the size of the list, which we're going to use the built-in function len for that. Numbers, colon, and then the body of the while. So the body of the while is the actual payload of the while, which in this case is going to be print. And I is 0, 1, 2, 3, and 4. And we want to print 1, 2, 3, 4, 5. So we want to print the actual integer value at position 0, not the position 0. So we do not want to print this because this will just print 0. We want to print the number that's there. If the number in here is, I don't know, 8, we want to print that 8. So we use square notation like this. Okay. Do not forget about that really important instruction, which should be inside of the structure that's inside of the body of the loop while, which is I equals I plus 1. So we increment the variable I, otherwise the variable I will continue to be 0 forever. And this loop will never finish, and it will write 8 hundreds of millions of times, like you see here. Okay. And now it printed what we want. So the first item, second item, third item, fourth item, and fifth item. And in fact, this is the behavior of this source code is identical to the behavior of this source code. It does not matter in which way you write it, it's going to do the same thing. But this is more error prone because you'll need to remember to start at index 0, not 1. This should be less than, not less than equal. In here, you should remember to not print I, but numbers of I. Then don't forget to increment the loop variable, otherwise you will have an infinite repetition, an infinite loop. So this is more error prone and harder to reason about without a piece of paper where you can write down the exact values that I takes, whereas this one is less error prone, simpler to read and comprehend, and more like the human language. Okay. Then, because this for syntax is similar to for each in C#, not to for in C#, how can we do simple fors, which in other programming languages you can say for item equals to 0, item less than 10, item plus plus. So for that, in Python, we have range, for instance, of 5. Let's see what range is. So it's a C. It's a class. A range is a class. Okay, and this is actually the class constructor. Let's store this range in a variable. Let's call them numbers. And let's print both names and the type of names. Not names, but numbers. Okay, so the type of this variable is an object of type class range. So this is an instance of the class range. And the default string implementation of the class range makes it such that when we print numbers, this numbers is an object, gets converted to a string, and this is the string it gets converted to. Again, this space is because print has two parameters, and after it finishes printing all of the strings which represent the first parameter, which are these, of the characters, then it puts a space, and then it advances to the second parameter and prints to the screen all of the characters of the string, which is the representation of this parameter, which are these characters. Okay. What does this 5 stand for? So as you can see, it's a range 0, 5. So this is a 0 is inclusive and 5 is not inclusive. So this is the interval 0 and then without 5. So including 0, excluding 5, integer ascending order. So 0, 1, 2, 3, 4, and not 5. Okay, so this is the first way of constructing a range with just one integer. And there's another way of constructing the class, which is similar to what we saw in slices. So we say where to start from, for instance 5, where to end to, for instance 10. So this is going to start from 5, contain 5, 6, 7, 8, 9, and not include 10. So 5, 6, 7, 8, 9. And now the range is not from 0 to 5, but from 5 to 10. A third way of constructing ranges is to pass to the constructor 3 integers. So this would be the start including, it would be the end excluding, and this would be the step. So it contains 5, does not contain 6, contains 7, does not contain 8, contains 9, and then should not contain 10 and should stop there. So from 5 including to 10 excluding, but then only only odd numbers. Okay, so 5, 7, 9 should stop before 10. Okay, we do not need to create a local variable if all that we want range for is in here, in the list that's used for iterating using a for. So we can have this directly. Okay, or without any step. A similar data type to list is tuples. So let's see both lists and tuples. So numbers equals okay, so this thing is correct. Numbers is a list. Okay, so 1, 2, 3, 4, 5 as a list, and then it also says that it's class list. But then what is this? What is this? What type is this variable now? So it's a class tuple, not a class list. This is a tuple literal. So it's a value of type tuple. We declare a local variable and assign it, so it's of type tuple, which is confirmed in here, and its value is not in between square parentheses 1, 2, 3, 4, 5, but between round parentheses 1, 2, 3, 4, 5. One of the most important differences between tuple and class is that, similar to a string, you cannot, for instance, change the item at position 0. In a string, you cannot change the character that's at position 0. So tuples are immutable. Let's try to do that. Numbers of 0 instead of 1, let's put there a -1. And it gives a exception of type error, says that tuple object does not support item assignment. So this is an item in a tuple, you cannot assign it anything. You can also see that a tuple is immutable by looking at the members, the member methods. So there's no member methods for sorting, reversing, appending, inserting. There's count, which is probably the same thing as len. And then, it has the parameter value, so it counts how often a value appears inside of the tuple and the tuple. And then there's this index method, where it searches for a value from a start index to a stop index. Okay. So you can see what's at each value, at each position. Numbers of 2 should be 0, 1, and 2 should be 3. And it is. So most of the time you use lists because you can modify those, but sometimes you want to convert a list to a tuple or to return from a function a tuple, or maybe you use it for performance reasons, for multi-threading reasons. You prefer a tuple instead of a list. So this was it. This was the tutorial Python for beginners, but with a faster pace. Thank you.